In this video, the poverty dataset would be analyzed. This dataset is related to SPM, which is Supplementary Poverty Measure, and this is taken from the US Census Bureau, where SPM stands for Supplementary Poverty Measure. This supplementary poverty measure takes into account several factors while deciding poverty, such as income levels, tax paid, educational levels, and many other factors as well. The following are some of the attributes in this dataset. For some are serial number, which is the household sequence number, and then the SP order, which is the rank of the individual in the household unit, and then ST, which is state code, and PUMA, which is public use microdata area, which the entire area is divided into smaller areas for uh, collecting information, and then of poor, which is the official poverty status of an SPM individual. 1 means poor and 0 means not poor, and this is decided only based on income, and then weight, age, and marital status, which can take the values of 1, 2, 3, 4, 5, indicating married, widowed, divorced, separated, never married, and then gender, which is either male or female, and then education, which which can take up the various values like 0, 1, 2, 3, 4, depending upon the education levels of an individual, and then race, which is white, black, Asian, or others, and then SPM ID, which indicates the SPM unit identification number of an individual, and then SPM poor, which indicates whether a person is poor or not after taking into account the supplementary poverty measures, and then SPM poverty threshold. If the SPM resources, which will be this, if the SPM resources, which is total SPM resources for the SPM unit, is greater than SPM poverty threshold, then it means that the person is not poor, which is 0. If it is less than the poverty threshold, it takes up the value 1, which indicates that the SPM unit is poor. And the SPM resources attribute takes into account several factors such as total, which is the income of a person, and then medical expenses, federal tax, and other tax related indicators as well, and then child care expenses, medical expenses, and so on. Now coming to the visualization part of the dataset. Here we can see the pair plot which corresponds to SPM poor, that is which indicates whether an individual is poor or not. For example, we can see with respect to education and poverty. Here, blue dot means that the person is not poor, and orange dot means that the person is poor. We can see that as the education levels go up, the orange dots start to decrease, which indicates that as education levels increases, poverty levels also start decreasing. And also with respect to age, we can see that as age increases, the poverty levels decrease, and after a certain age, it slowly starts increasing by a certain extent. This can be explained due to the fact that a person gains more money with his experience, and uh, his earnings stagnate after the retirement period. And we can also see that some races are poorer than the others. For example, here in our example, blacks are quite poorer when compared to whites, and also we can see that others like Hispanic are also slightly poorer when compared to the majority whites. We can also see the count plot of poverty, which is SPM poor. Here we can see that for every 2.5 non-poor persons, there is almost zero point 0.4 poor person, which means that almost 1/6 of the population can be categorized as poor when we take the supplementary poverty measures into account. Whereas when we take the official poverty status, mm, which is only based on income, we see that the number comes slightly lower than the SPM1. And also we can see that the individuals belonging to the first education level, which is minimum or no education, are the highest in number, followed by the highly educated ones like bachelor or master's degree, followed by the college degree ones, and then the school dropouts. And we can also see that the whites are the majority in US, followed by blacks, followed by others like Hispanic, and then Asians. Now coming to the distribution, here is the joint plot between Age and SPM resources. Here we can see that there's no simple correlation between the two parameters. However, we can see that as age increases, the SPM resources starts to increase, although there is no perfect correlation between the two. And we can also see that the two attributes don't show normal distribution based on the graph that we can see here. And now coming to weight versus SPM resources. And we see that weight follows a normal distribution. It shows the characteristics of a normal distribution, whereas SPM resources doesn't. And then coming to the box plot, we can see that the variable SPM resources has got so many outliers characterized by these black dots that can be seen here. The black bands are the normal black bands are the regular values taken up by the variable, and the black dots that can be seen here are the outliers. We can see that there are some significant outliers with respect to SPM resources. When it comes to age, we see that there are almost no outliers at all with respect to this variable. Here is the pandas profiling report of the dataset. It can be seen that there are 40 variables in the dataset, and there are no missing variables, and there are also no duplicate rows. And some of the observations that can be made are SPMResources is highly correlated with SPM total, which means that SPMResources is highly correlated with income. And also SPM federal tax is highly correlated with SPM resources. In education column, we can see that the mean education of an individual in US is around 2, which means that an average person in US attains up to high school education degree. It can be seen that 28% of the population have very little education or are pursuing education, whereas 24% of the people in US are only have up to a low school education levels, whereas around 21% have up to high school degree as an education level, whereas around 19% of them have a college degree as an education level, and the remaining 7.5% have a higher degree, such as a bachelor's or a master's degree. It can be seen here that 37.7% of the population is poor. In this data set, we see that there are no null values. We see that the number of null values is 0. So that means we don't have to remove null values. And now coming to the distribution tests. First, with respect to SPMResources. After plotting the cumulative distribution function on the variable SPMResources, it can be observed that the graph is not too different from the normal distribution. Hence, we can't rule out anything at this stage. Again, with respect to age, it can be observed that it doesn't deviate much significantly from the normal distribution. So, again, more tests have to be performed to ascertain the distribution. After that, probability distribution function was applied on SPMResources and age. After applying PDF on SPMResources, it can be seen that there's a sharp spike in the column SPMResources, which means that it deviates somewhat from the normal distribution. Again, when it comes to age column, we can see that there's a sharp spike, which is not the characteristic of normal distribution. Also, it was observed that the mean, median, and mode are not equal, whereas in normal distribution, mean, median, and mode of an attribute are equal. It can be seen here that the mean, median, and mode are not equal. Next, chi-square distribution test, that is, chi-square goodness of fit distribution test was performed on these attributes to determine whether they fit in normal distribution or not. After applying chi-square distribution test on SPMResources, it can be seen that the attribute closely resembles log norm distribution and also somewhat resembles inverse Gaussian distribution, whereas it deviates significantly from the normal distribution. Hence, it can be ascertained that the column SPM resources doesn't follow normal distribution. Again, with respect to age, it can be seen that the column is most closely related to beta distribution and it significantly deviates from the normal distribution. Hence, it can be said uh, that the attribute doesn't follow normal distribution. Now coming to the hypothesis testing between the various attributes. Here, on performing chi-square test between gender and poverty, where null hypothesis says that there is no relationship between gender and poverty, whereas alternate hypothesis says that there is a relationship between the two variables, gender and poverty. Here it can be observed that the p-value is less than the level of significance 0.05, which probably means that there is a correlation between gender and poverty. After that, hypothesis test was also performed between education and poverty. Again, it was observed that the p-value was less than alpha value or level of significance, which was chosen as 0.05. Hence, the null hypothesis can be rejected and it can be said that there is a correlation between the two categorical variables. Next, Z-test was performed to determine the correlation between the discrete variables. Z-test was performed for hypothesis testing for the same. Here, it can be observed that there is a correlation between age and SPM resources after Z-test was applied on the two variables. Here it can be seen that the p-value is less than the alpha value or level of significance, which probably means that there is a correlation between the two variables. Again, same with respect to age and childcare expenses. On applying chi-square test between gender and education, it was observed that the p-value is less than alpha value and there is probably a correlation between gender and education level. Also, Z-test was applied between Age and SPM resources, and here it can be observed that the p-value is 0, which is less than alpha value or level of significance, and hence the null hypothesis can be rejected, and it can be said that there is a correlation between SPM resources and age. Again, the same can be said with respect to age and SPM poor, which probably means that age and poverty are related to each other. On those columns which were not normal, Box-Cox transform was applied to transform them into normal distribution. Here is the Pearson correlation coefficient heat map of the dataset. Here it can be seen that there is a strong correlation between age and education. There is a strong positive correlation, which means that which is quite intuitive, which means that as age increases, education levels also go up. And it can also be seen here that there's a negative correlation between education and the SPM poor, that is poverty level, which probably means that as education levels go higher, poverty levels start to come down. And also we can see that there's a positive correlation between race and poverty, which probably means that some of the races like blacks, Hispanics are comparatively poorer when compared to the majority whites. And here it can also be seen that poverty is related to childcare and medical expenses, which is quite intuitive since the more the more money you have to the more money one has to then he can spend more on these expenses. And it can also be seen that there is a small positive correlation between age and poverty level, which means that as age increases, the poverty levels start to go down. Since individuals start earning more money with experience. And it can also be seen that there's a significant positive correlation between marital status and poverty level. And on this dataset, Z scaling was applied to normalize the data, or and the for performing feature scaling, Z scaling was performed. Later, the dataset was divided into train and test set. And various machine learning algorithms were applied. First, Knn algorithm was applied. Here it can be seen that it provides an accuracy of 95%, precision of 83.5%, and a recall of 81%, which means that this algorithm gives good results on this dataset. Next, random forest algorithm was applied. Here it can be seen that it gives a high accuracy and a high precision value and a recall value which is slightly lower than the Knn algorithm. Later, XGBoost algorithm was also applied. Here the results of the same can be seen. It can be seen that XGBoost algorithm gives good accuracy and a very high precision, but a lower recall when compared to the previous algorithms. Logistic regression algorithm was also applied on the dataset. It can be seen that it provides a decent accuracy and precision value and a recall value which is somewhat lower than the Knn algorithm. ROC curve was also plotted, and it can be seen that it is quite far off from the 45-degree line. Next, Bayes algorithm was also applied, and it can be seen here that it gives a lower accuracy than the previous algorithms and a very low precision and recall value, which means that this algorithm cannot be accepted since since we can't classify non since we can't classify poor people as not poor. On applying all the algorithms, it can be seen that Knn gave the highest accuracy or close to highest accuracy and highest recall, and it also gave a decent precision value. Hence, Knn algorithm was chosen since it is important to choose an algorithm with a high recall value on this dataset because a poor person cannot be classified as not poor. And on the same algorithm, that is the best algorithm Knn, it was it was plotted on to check which features were the most important for this algorithm. It can be seen that feature 2 and feature 4 important are the most important features for this algorithm. These two features explain most part of the algorithm, which is gender and SPM resources. These two resources explain or help in solving most of the algorithm. Thank you.